All right. So, if you weren't aware of it, polygon is basically a general name for a shape. So anything like a triangle is an example of a polygon, a square is an example of a polygon. So it's a multi-sided shape. And it might be worth using the word closed. And what I mean by that, it can't have like a gap in one of the edges. So we've been talking about polygons this year when we talked about triangles, but now we're going to talk about more sides than that as well. I feel like a lot of people said that January was going slow, and I thought it went really fast. I don't know if like final exams in the middle like made it so it seemed like it was faster for me or what, but okay. Now, in terms of our polygons, and I'm going to use the board up here as well to help us with this, but polygons are basically going to be made up of triangles, and that might sound like a weird thing to say. So what I can do is take any polygon and I can break it up into some smaller shapes. I can break it up into triangles. So we start with a triangle. Then I have like a rectangle or square, and then I can have like a pentagon. What I'm going to tell you guys is that we can take any of these shapes and then we can break it up. So like I have my rectangle here. If I just draw a line connecting two of the vertices, there's two triangles in my rectangle. In my pentagon, if I connect that vertex to two of the other vertices, there's 1, 2, 3 triangles in my pentagon. So every single one of these shapes, we can break it up into a series of triangles. And that's going to help us to understand about the measures of the interior angles of any polygon. So we're going to start with triangles on our chart here, because there's no shape that has less sides than a triangle. 2 sides is not enough to form a shape. So our triangle has 3 sides. And in our triangle, there's 1 triangle. Now, what do we know about the sum of the interior angles of a triangle? What do they add up to? They add up to 180, or what? Ariana, what'd you add them up to? 180.03 on her test. Was one of her donuts. She had a moment. So our triangles would add up to 180. We're going to use that pattern to help us to fill the rest of this table in. Our next shape is going to be 4 sides. Now, this might be a shape that you might want to call it a square or a rectangle. Is there a less specific name for a 4-sided shape?
Parallelogram.
That's a less specific, not enough. We need to go less specific than that. Yeah, that's the one I'm looking for. Now, again, I was given parallelogram. That's an example of a quadrilateral. A quadrilateral, like the overarching, kind of like we're all random like rams. And then there's specific, grades within that. So it's not wrong to say that you're a sophomore that goes here, but we want to be more general. So in our quadrilateral, which this rectangle I drew up here is an example of a quadrilateral, there's 2 triangles in that rectangle. And you might already know this, but what would the sum of the interior angles be then? It's 360, because there's 2 triangles, and if there's 2 times 180, that's 360. And if we think about it, an easy example of a quadrilateral would be an example of this rectangle here. And all the corners are 90 degrees. If they're all 90, 4 times 90 is going to be 360. So that's going to be the case for all quadrilaterals, though. So our next one is our 5-sided shape, which I did actually already name as a pentagon. Now, in terms of knowing the names of these, I am not going to test you specifically on the names. The ones on this chart I expect that you probably would be okay with, but at the same time know that most of them I'd probably let you look up, or I would tell you what it's going to be for number of sides. The number of triangles in a pentagon, we drew it up here, would be 3. See if I can get my thing to... So 3. So our sum of our interior angles, we're going to get what for that? Colin, what'd you get for that one?
For the pentagon?
Yeah.
540.
Yeah. And if it helps for you to write down a pentagon, like what it kind of in general looks like, it's probably not a bad thing to do that. So 540. And if you're realizing that we're getting that from 3 times 180, we had 2 times 180, or 2 times 180 up here. So our next one is 6 sides. And I'm gonna let you guys know, I know you probably want to fill the pattern in. We're gonna stop there. We're gonna call the next one N, and we'll talk about that. So like in general, what's the rule? So 6-sided, does anyone know that name? Hexagon. So our hexagon, I'm gonna draw one that's a pretty straightforward one here. So that's our hexagon. And now again, if I want to draw triangles in this one, I'm going to take connect the vertices. So there's 1, 2, 3, 4, if you didn't guess that that was going to happen. So we do 4 times 180, and what do we get for that one? 720. My thing's being a little laggy today. Okay. Now the next one, rather than kind of keep doing this pattern, because it's getting, hopefully you're realizing. So if we don't know a name for a shape, or sometimes the book will just do this, they'll just call it an n-gon. So it's kind of like they didn't want to give it a name, or they don't really know, or we don't have a name for that type, we just call it an n-gon. So every once in a while I'll just do that instead of calling it, looking up what, like a 15-gon is. I don't really know that. So I might just call it an n-gon. So based off our pattern here, based off the number of sides, can we tell how many triangles it's going to be in an n-gon? How would you explain that using n? Yep.
N minus 2?
Yeah, it's always going to be the number of sides and then subtract 2. Because all the ones above, it's always 2 less than what the number of sides are. So then the question is, what would our formula look like for any shape? Yeah?
N minus 2 parentheses times 180.
Yeah. And just because of algebras, the way I typically write it in algebra, I'd probably write it this way, but the way you said it's just fine. We're taking 180 and multiplying it by n minus 2. Okay? All right, so now we're going to start showing how we're going to use that in different types of problems. So depending on what information they give us, and so okay, so it says, find the sum of the interior angles for a decagon. A decagon is a 10-sided shape. And so, for example, something like that is maybe something you know, but at the same time, I'm not testing you guys on naming all the shapes. I don't really know where that takes you in life, is knowing what a decagon is. But being able to solve that and know what that sum of the interior angles are is a good problem-solving thing to know how to do. So they're giving us the n, and so we're just going to put that into our formula. And that just becomes 180 times 8, because there'd be 8 triangles in a decagon if you followed that pattern. And so again, this just becomes multiplication here. So 1440. And please use the degree symbol. Again, on the test, I only took off one time if you forgot to use the degree symbol. So like if you forgot on every question, you lost 1 point, but if you only forgot on one, you also lost 1 point. So that's kind of annoying, but I was just kind of watching to make sure I didn't take off a bunch of times for it. Our next one is a 17 gon. And so again, that's our N. So that means a 17-sided shape. And so I'm doing 17 minus 2, which would be 15. And so what you're going to realize here is pretty quickly, the sum of the interior angles starts adding up really, really fast. And if you think about it, as the shape gets bigger and bigger, the angles get bigger and bigger. So like I have this goofy little tool, I don't know why I would use this very often. But like, so like a 10-sided shape here, I have this, it lets me draw it. So here's a 10-sided shape. So if you picture a 17-sided shape, it's probably almost looking like a circle. And those angles are getting so large, and there's 17 of them. So that makes it more and more like circular in terms of our shape.
They have 12 up there.
Yeah, they have 12 as well. I just was picking the 10 because of, yeah. After that, it would just kind of become silly, I think, so they wouldn't even bother. Why did that move? So yeah, there's 12, but yeah, you're gonna notice probably not a huge difference. Here's 12. So again, there's just a couple extra sides. But as they get bigger and bigger, it's really hard to draw those. All right, so the next problem is asking us to do the opposite of what we just did. They tell us the sum of the interior angles, and they want us to find how many sides it would have. So we're finding N. So basically, we're going to take that formula that we kind of came up with and set it equal to what we know the sum is. And it's up to you guys how you guys want to solve this. I like distributing first. Instead of distributing first, you could just divide by 180. So this is just being a little laggy today. So then I would move the 360 over. $19.80. Some of your parents were probably born in 1980. And divide by 180. I only say that because I was born in 1979, so I was a year old in 1980.
1970.
A little bit older, yeah. I'm sure he's glad Mom and Dad are glad you're disclosing that.
They both know it. They're
Yeah,
always
right.
the oldest in every single parent group.
All right.
They also know it's like everybody my parents are.
Okay, so guys, and I just want to show you guys another way to solve this. We can just divide by 180 right away. And that might be an easier way, especially on one like this, because 360 divided by 180 ends up being 20. And so then I would just add that 2 back over. So again, we kind of are talking about some crazy shapes, 22 sides, 11 sides. I mean, those are some shapes that, especially 22, trying to draw that would be kind of crazy. All right, so our next problem asks us to find the value of x. If you look, they give us a shape here that's kind of this wonky looking, like, I don't know what that is. But we have to count how many sides it is to figure out the sum. So I look at this, and I count how many sides there are. 1, 2, 3, 4, 5, 6, 7. 7 sides, right? So we have to first find the sum. So we have to find out how many, what's the sum of the interior angles, and I know I'm going to do 180 times 7 minus 2. So 180 times 5. So that ends up being 900. So these angles should all add up to 900. And so this just becomes a giant algebra problem. So what I'm going to do is try to be a little bit more streamlined about it. I'm going to put all the x's together first. So it looks like there's 1, 2, 3, 4, 5 x's. Do you guys agree with that? I'm not missing any. And then we can add all the constants together. Notice one of them's negative up there, so be careful. I think I got 270. Did you guys too?
Yeah.
So I had to first talk about what the sum of the interior angles are, and now we're going to just solve this algebra problem. And then I'll just divide by 5. And that'll give me the value of x. And now on some of these, bear with me, some of them you might look at it and say, well, that doesn't really look like 126 degrees, or those shouldn't look the same. Just know that sometimes when I draw these, it's kind of just, I'm hopeful that it makes some sort of sense in the problem. But so like the angle here, they're saying that would be 126 degrees.
Which looks
That seems
plausible.
okay, yeah. All right, so we're gonna flip the page over when you guys are ready. So we need to talk about what a regular polygon is. So a regular polygon is kind of the kind that if you went down to kindergarten and talked to I don't remember what grade you learned shapes in, but let's say whatever shape you learned about a pentagon, they would probably draw, like you said, point out a regular polygon, or pentagon, they would probably draw this one. It's kind of like your stop sign type octagon. It's the regular, like the one that you would draw if you were drawing the most basic version of it. So a regular quadrilateral would be like a square. And what that is, it's a polygon with all equal sides and angles. So it's our equilateral triangle. And so actually I'm going to cheat because I have this tool that draws those for me. So my regular polygon is an equilateral triangle. All the angles are 60. My regular quadrilateral would just be a square. Regular pentagon, and I obviously can keep doing this and annoying you with my perfect shapes compared to probably what you're drawing, but not saying you can't draw these perfectly, but obviously it's not the easiest thing. So yeah, and the pentagon, so the one you draw, that's a house, so that would still be a pentagon, but it wouldn't be a regular. And I just want to make sure that's clear. That doesn't mean it's not a pentagon. So if I drew a house, this is an example of a pentagon, but not a regular one. So just kind of making sure that that's clear, because all the angles aren't equal. Most of the polygons we're going to talk about today are going to be convex. And I'll explain what that is. It's all the angles, I should say all interior angles. So a convex polygon is where all interior angles are less than 180. And this is probably the type of polygon, again, that most of you guys would be comfortable with and recognize and know that it exists. So like the ones we've already worked with. Whereas concave is where one of the angles, the interior angle could be greater than 180. And so an example of that would be something like this. So you wouldn't think of that as a polygon, it still is, it's just called a concave polygon. Because this angle, technically, that interior angle would be technically greater than 180 degrees. So it's kind of like one of the sides of our house got kicked in. There was a national disaster.
Earthquake.
Yeah. Tree falls on the house. All right. So now we're going to talk about how to solve some of these other pieces of problems with these. So it says a measure of an interior angle of a regular polygon is 150 degrees. So one of the things, it says find the number of sides. Now since it says it's regular, that means all the angles and sides are equal. And since we're talking about angles, I'm going to talk about the sides, or I'm going to worry about the angles instead. So they're telling me the angles are all 150 degrees. Another random shape here. I don't know what's, maybe that's the answer, I don't know. Okay, so if all the angles are 150, how many angles are there? Do we know that yet? We're trying to find the number of sides. That's the number of sides. But the number of sides and the number of angles is the same thing. So if the number of sides equals the number of angles, they're both n. So we're trying to find n. If each of the interior angles is 150, to find the sum, how would I do that if I know how many angles? What did we do with that? So if I know there's 10 angles, what would I do? Yep.
Would you multiply 150 until it makes it like a multiple of 180?
Well, that's not a worst idea. That might work, but it might be kind of annoying to do it that way. So he was saying keep multiplying 150. What I'm going to say is let's multiply 150 by n. I don't know what n is. But let's say that n was 5. I would multiply 150 by 5, that would be my sum. If I'm trying to find n, I can set this equal to the formula we just came up with on the front side. Both of these should be my sum of my interior angles. So we're going to be able to solve this equation for our n. Now again, I like to distribute first typically. I'm going to move that 180n over. And so we're going to divide by negative 30. And so we're going to find out n is just 12. And maybe that's, which is what I must have drawn there and forgot I put it there. So this is saying that each of these interior angles is 150 degrees. It just happens to be there's 12 of them. So that's how our, that's another way to solve this. So there'll be some questions like this where you're trying to find that interior angle, or the number of sides. Now we're going to talk about exterior angles as well today here. We'll finish up with that, and then you guys will have some time for homework. Just a reminder, we drop tomorrow, so any homework we get tonight is due on Monday. So this next problem, or next type of problem we're talking about is the polygon exterior angles. So what exterior angles are is basically so the example, the drawing I have here is an example of the polygon exterior angles. So these are formed by extending each of the vertices one time. So, so the number of interior angles If n's the number of interior angles, that should also equal the number of exterior. So since this is a three-sided shape, there's 3 exterior angles. It's your brother making you laugh. All right. So I'm going to show you guys something that's kind of interesting, maybe. Oh, maybe math interesting, not normal people interesting. So, all right. So if I have my equilateral triangle here, these are all 60. If I want to draw the exterior angles, so here's one exterior angle, here's another, here's the third. What do I know about all those exterior angles? Make sure we're focused up here, please. You'll see, yeah.
Equal.
They're equal to each other. So if this is an equilateral triangle, these would all be equal as well. So do we know what they would be? Yeah. They'd each be 120 because they form a straight line. So this would be 120, this would equal 120, this would equal 120.
We kind of learned about this earlier.
Yeah, when we talked about the exterior angle a little bit. Yeah. Now what would those 3 add up to? 360. 120 times 3 would be 360. So let's do the same thing with our rectangle here. So if I extend this and give each of them an exterior angle, which of each of those exterior angles going to be? 90. So what would they add up to? They would also add up to 360. I'm going to tell you, spoiler alert, this is always the case. So the sum of the exterior angles, regardless of how big these shapes get, it's always going to equal 360 degrees. So this is kind of like, it's kind of almost a hard thing to wrap your head around until you start kind of actually like looking at it individually. So the sum of the interior angles, or exterior, sorry, so it's always going to equal 360 degrees. And the fact that there's 3 sides, 3 angles, interior and exterior. So the drawing down here says find the value of x in the diagram. So this is a quadrilateral. It's not a regular quadrilateral, it's just a quadrilateral. Just your run-of-the-mill quadrilateral. But I know that the sum of the exterior angles should just add up to 180. So we're just going to add those up. So 2x and 6x is 8x. 130, oh no, and 9x, sorry, 17x. Oops, plus 139 is going to equal 360. So again, this just becomes an algebra problem for us to do. So 17x will equal 221. So we find out x is 13. So we found the x value for each of these. Now our next question here says the measure of each angle of a regular dodecagon. If you don't know, a dodecagon is a 12-sided figure. So again, if there's anything you don't know, I'm fine with you Googling it. It's 12 sides. So again, using that shape we had up above, our little dodecagon here, regardless of the fact that this one almost looks like a circle, if I extend each of those, what are they all going to add up to? 360. And there's how many of them? 12. So we're going to say 12x equals 360. So we're going to divide and find out each of the exterior angles is going to be 30. Yeah. Yeah. And let's take a minute though, real quick, before you guys get going on homework here. I want to connect that back to the problem we just did before. So in this one, we said each of the exterior or interior angles is 150. And we found each of the exterior angles is going to be 30. Remember that the interior angle and exterior angle,
Always equal 180?
yeah, they should always add to 180 together. So here we have an interior angle. And then here we have an exterior. So really on this problem, I could have used that to kind of help me if I would have known that already. Sorry, this board is being goofy. All right, so questions there with that all, like just understanding, again, this is different from what you've seen before a little bit, but it does connect some of the things we've talked about, those linear pairs. Oh gosh, sorry, I didn't have this on here. I'll have to flip back my video.
You forgot about the camera.
Yeah. So, the homework is listed there for you guys. Apologize in the video. I flipped the screen there on us, so you might need to take notes again here.